With the frame assembly completed, I'm now ready to bring in the motor. So I'll place the motor in the assembly, and it's a 2-bar motor 393 model. To assemble the motor, I'm going to place 3 constraints. Let's rotate that around so that we can see them a little better. So the first constraint is going to be the axis. I'm going to align that with the bearing flat on the other side because I know there's a circular edge I can get there. Hover and select the axis. Apply that, and similarly with the second one. Select the axis, and on the second hole on the bearing flat, select the axis from the list. I'm going to apply that. Actually, we'll click on cancel and we'll drag that out. I have one more constraint to add. That's going to be a mate constraint between the face of the channel and the face on the motor. So select the channel and then select the face on the motor. And that constrains the motor to the assembly. Now what I want to do is rotate the gears. Now we can see that, well, that's not working, is it? But if we think back, what actually happened was we put in an angle constraint to align the gears. So I need to suppress that. With that constraint suppressed now, that gear is moving, and is the small gear, but not together. So we need to apply another constraint, and that's going to be a motion constraint. Leave the default solution. Select a circular face on the small gear and then on the large gear. So the ratio then will be 12 for the small gear and 36 teeth for the second, or 1:3. Now when I move that, that looks a lot better, but looking at the alignment of the gears, when I tested that, I think I made a mistake with the gears. So I'm going to go back, unsuppress that, then suppress it again, and that realigns the teeth of the gears correctly. And that looks pretty good. So I can turn on the visibility of the channel again. I've turned on the visibility of the parts I turned off at the beginning of the process, so we can see that the scoop bucket is working correctly. You want to double check that everything is moving. Shaft collars, the lock bar. You may have forgotten to put an angle constraint in, and now is a good time to check that. I want to be able to drive my design, so I'm going to put an angle constraint between the shaft that goes into the motor and the face of the channel. And we'll leave that at 0 degrees. Now, of course, when I try to move things, it's locked because that constraint is there. Let's go back and find that constraint. And as I've been doing before, let's rename that. And we'll change that one to Drive Me Motor. And again, that's easier to find. As we've seen before, I can suppress that constraint. Check that everything's working correctly. But what I want to be able to do is drive this constraint. So I'm going to take the suppression off, and as by right-clicking, I'm going to drive the constraint. I'm going to drive it through 60 degrees. Now that 60 degrees is actually on the motor, on the small gear. So you'll notice that the bucket only moves through 1/3 of that, or 20 degrees. So let's make that a bigger value. And you can see the effect of the 1:3 ratio here. So this is a very good way of using the Autodesk Inventor model to test if your design will actually work. We're now back in the full assembly. And what I like to do here is look at other possible solutions. This is the 36-tooth gear, giving us that ratio of 1:3. But we also have the possibility of a 60-tooth gear and an 84-tooth gear. I know the 60-tooth gear will work. I've actually tried that particular one. It will fit in here. The only thing you have to do is move the motor assembly 1 hole to the right. You wanted to give that a try.